All right. Good afternoon, everybody, and welcome to my talk. You've got pwned, exploiting email systems. My name is Inti de Keukelaar. I'll do a quick introduction of myself. I come from this beautiful country in Europe called Belgium, so excuse me for the accent. I currently work as a community manager at bug bounty platform Integrity, where I basically get to tweet on their Twitter account and be the voice of the hacker community. I really love live hacking events. I've participated in quite a few of them, mostly organized by HackerOne, so I definitely have some experience with that. And even in 2018, I was lucky enough to win their flagship event in Vegas, basically H1702, where I walked away with the Most Valuable Hacker award. So that was kind of nice. But in all my research and even at these live hacking events, one thing that always comes back are emails, and I've made a fair amount of bug bounty exploiting or finding bugs in email systems or emails themselves, and I hope to share some of this information with you today. So first, I'll go on and explain why exactly I do like emails that much. First of all, emails just contain a whole bunch of confidential information. And if you don't believe me, I challenge you to just go to your inbox and open a few links or emails that still make it to your inbox and not get filtered by the spam filter. Usually, we send and receive quite a lot of confidential information. Nobody likes their emails being breached, so it's always a very interesting target for hackers. Also, they contain certain links that allow hackers to break into systems, such as password reset links. And emails have been around for quite a while, and people just use it for all different purposes. You have ticket trackers, you have people just integrate it within their system. So it's kind of complex for such a simple thing, which is just basically the essence of it is just delivering messages or attachments or files. But there's a lot of edge cases and implementation mistakes, so that's why I really like it. It's also pretty old standard, and over the past few years the standard has changed a little bit, and we made it a little bit more secure. But yeah, it's still very interesting to study for vulnerabilities, and also every app uses it. Name a web app that doesn't use emails today. I mean, that's nearly impossible. So that's why I use it as my main target when participating in bug bounty programs. So let's take a look at what we'll cover today. First, we'll talk about email addresses themselves, and then we'll go into the email itself, so basically the email that you send out, and then we'll discuss, okay, what can go wrong in all around that, which basically is, for example, spam systems, autoresponders, and all the systems and behaviors really of how emails interact with systems will be covered in that last topic. But let's take it one step at a time and take a look at email addresses first. For this particular part, we're going to see what kind of interesting payloads and valid email addresses can contain, and then we'll also see, okay, how does the web application, how do they react to these payloads, and how can we get our interesting payloads into these web applications even though they don't support it right away. So first part, payload crafting. So this is a very normal representation of an email address. I mean, that's kind of obvious. You have a local part, you have the @ symbol, and then you have the domain. But email addresses are much more than that. If you would look at the specification, of course, they can just contain Latin letters, they can contain digits, dots, but no two dots after each other. They don't like that, so it's prohibited. But I don't think many of you know that you can, for example, have an exclamation mark or like an ampersand, for example, in an email address. which is perfectly valid. And most web applications that use a decent validator will actually accept that. And also for international purposes, there's more and more support for the more exotic looking email addresses, which also, brings a couple of problems with it, like homograph attacks, but we won't cover that in this talk. So what's interesting and something I found a couple of years ago, and I didn't know it existed, was that if you quote email addresses, so basically put the local part between double quotes, you can even add some more characters. And the most interesting part is that you can also add, for example, a less than sign of a greater than sign, which can be used to inject HTML. So every email address that you see currently, even that with the double at, are actually completely valid email addresses. You can even have a space in them and even an emoji. I mean, it's just a valid email address if it's quoted, and not a lot of people are aware of this. Then there's also the fact, and I'm sure quite a lot of you use the basic version, which is basically for Gmail, for example, you have to append a plus sign and then you can write some gibberish, are the wildcards and the comments. For example, if you just say, okay, I have a spam email address, for example, and I filter out everything, but I still want it to come into my inbox. You can just add something and then the final result will still be delivered to you, but you'll be able to filter things out based off of this wildcard. And then there's another standard, and I've never ever seen this used in a real life scenario, but it's still in the RFC. You can include comments between parentheses. So just like JavaScript and HTML, you can even have a comment in an email address. Email parsers or email processors will just end up ignoring it, so the email will still get through. But that's also quite a interesting factor we'll play with today. And then there's the domain part, which is a little bit more strict. Obviously, we also have the Latin letters, we have the digits, hyphens. But what's really interesting here is that you can have IP addresses. I've never seen a successful email address to an IP address. I would have to look into the standard, but definitely for very specific vulnerabilities, if this is a valid email address, I mean, we can have some, we can create some interesting SSRF payloads with that. So that's why I've included those. Okay, so let's start crafting with the information that we have now. And the orange is basically, it's not entirely valid according to the RFC, as these characters would have to be double quoted, so like here. But still, I found during my research that quite a lot of email address parsers would actually accept it, so that's why I mention it. For example, this email address, just test and then the wildcard and then the parentheses to indicate a comment and then just a cross-site scripting payload. There's a lot of websites that would actually think this is a valid email address and probably have you confirm it and display it in their application. Problem is, if they don't expect an XSS payload in an email address, which is something that developers generally don't expect, and they don't properly sanitize it, then it will result in cross-site scripting. I've seen this happening quite a lot of public and very big HackerOne programs, so it's definitely a thing not a lot of people are aware of. And this would be the entirely valid version according to the RFC. However, I've seen this working more than this part, so it really comes down to the local implementation or the interpretation of the RFC. By the way, you can also put these things in the domain part, because you can have comments in the domain part and then it will just ignore it and send it to your email address anyways. Now we're using script, which is ideal for testing cross-site scripting, for example, within an application, but I would always recommend you to try HTML injection. For example, I send an email from this email address or to this email address, and the email would actually use the h1 tag and render it. So obviously just normal emails like you would receive in Gmail, they won't be able to execute a script tag, but you may have an HTML injection. So don't only test for script tags, only just test for generic HTML tags as well. Of course, there's also template injection. You know, a lot of email addresses, and you'll have to check in your own inbox either above or below. And this could be because of some privacy or tracking reason. They will actually include the email address they've sent it to, and if that contains a payload and they didn't properly execute it, it can result in cross-site scripting or template injection. And usually it's like a sentence: this email was sent to blah blah blah. It's usually in very small letters, but always make sure to check that, because if you can get a payload in that would be interesting. These are some example payloads that would also be valid. For example, if in case of a successful template injection, you would see something like this, which obviously just rendered or executed this one. So talking about that, and this is a while ago, but I think it's still quite a funny story. I signed up for HackerOne with the following email address, and nothing happens. So basically it was just sitting there in my account, and I received all emails using this, but since it's using a wildcard, it would just come through. So I didn't really feel the need to change it after testing it. And then like months after I injected it, I got an email from Michiel from HackerOne, the founder, one of the founders, and it was actually sent to inti.the.keukelaar and then +49 So I was like panicking. I was like, yeah, finally my payload got executed. I was very excited, and I thought, okay, I have something in a HackerOne system rendering my template payload. So I was writing up my report, but then it turned out he was just probably looking to the records and sending some manual emails, and he was just trolling me. So Michiel, if you're watching this still hurts. So all Michiel did was just replace my email address and put a 49. It would still come through. And I would think I had a valid bug in HackerOne, but unfortunately it was just a joke by Michiel. There's also SQL injection, obviously, and using this technique would actually also uncover some SQL injections that's using normal black box testing just by putting some gibberish in the email, or just by putting a non-valid email address containing a SQL injection payload in the email address. It wouldn't be discovered because most of the times what happens is they check whether the email is valid first, and then they execute a query, and then, I mean, it's MD5. It's just an example, by the way. But in the password here, it wouldn't be vulnerable because it gets hashed, but the email would be. As you can see, you can just break out of the query and add something yourself. But in order to do that, the email would have to be valid. So if you would set the email address to this, for example, which is a valid email address and still valid for the SQL query, then it would look like, there's like that. Yeah, okay. So like that, and obviously that's a valid injected query, and you would be able to set a password of another email address using this trick. So that's always very interesting. And then there's also, I talked about this earlier, but then there's also SSRF. So you can, in order to test this, for example, you can register with the Burp collaborator email address and then look for a HTTP request. Obviously not for a SMTP request, because that's normal. But if there's an HTTP request, and usually this happens because the applications tries to check whether the host is up, for example. it can result, basically it's blind SSRF, so then you can check whether you can redirect it or make it call internal resources, for example. So I mean, nearly every website has a register module, and they will somehow try to contact or send an email to the email address you signed up with. So it's definitely always something I check at least. And I have to admit, I haven't really encountered this a lot in the past, but sometimes when you sign up and it does this check to see whether it exists or not, and you use an internal IP, you'll get an error when the internal IP does not exist, and you won't get an error if it does exist. But then again, it's a very rare case. Then there's also and I think this is quite an underrated vulnerability, especially when it comes to the server side. It's parameter pollution. So basically, you would include another parameter in your email address, and this is a perfectly valid email address. And what would happen if they're using a proxy, or they're making a second request on the backend, and they just include your email address somewhere in another server side request, then your email may end up being replaced by this one. So the email parameter basically gets overwritten, and if you're lucky, the actual app that will process it will take the second value instead of the whole or the first value. So you would be able, for example, to retrieve data from somebody else in this example, if they would query the email, the data by email address. It's really hard to find, and obviously it's a lot easier to encounter during white box assessments, but it's definitely something you should be in the lookout for. Then there's also HTTP or SMTP header injection. Also, it quite like it depends. I haven't seen this a lot. I know Albinobugs has done some research on it. But basically, this also happens if you try to register with something, and then it connects to it connects to some SMTP interface, and you'll be able to inject some additional comments or additional statements in the command by just using a new line, and then it gets executed. I gotta say, I haven't encountered this myself in the past, but since it's a valid payload, you should be looking out for it. So this kind of sums it up. These are the. I'm sure there's more valid payloads. So if you spot some other email addresses that would also be valid payload for traditional testing techniques, make sure to put them in the comments below, I would say. And then another, and this is more business logic, but another way I've seen this being abused is by using domain whitelists. And I put Slack as an example here. I gotta say that Slack was not actually vulnerable, but I know if there's one domain or company domain validator, most of you would know it's actually this one, so I'm referring to this one. But as you can see down here, it says, okay, if you have a Cyanide, Bookrat, Zerocopter Integrity, Google, blah, 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 email address, you can just create an account. And obviously people that don't have it cannot join the Slack workspace unless they're invited. So if you would sign up, you would get the drop down, and it would look like this. So in some cases, I've seen this once, so I'm not sure if it's very common, but in some cases what you could do is you would enter this perfectly valid email address, and then if it accepts it and passes it to whatever service is sending the email addresses, it might see the semicolon, and it will, most of these services will see a semicolon as, okay, I have to split this, I have to send this to multiple people. So the first email address, or invalid email address they would try to send it to is this one, and then this is my inbox, and then this is the third one they would try to send it to, which includes the company domain, so it makes it a valid company domain email address. But the final email gets delivered to my inbox, which obviously is not part of the company domain. So like I said, Slack was not vulnerable to this. It's a theoretical example with at least one occurrence of it being exploited in the wild. So it's also something, if you see a mechanism like this, make sure to test something like this. And another very fun example of possible exploitation in the wild is you can send to Gmail. If you have a Gmail address, you can just use the wildcard and send this string to your Gmail address, and it will actually render. It will still work. Obviously, it's not vulnerable to cross-site scripting, otherwise the Gmail team would have fixed it right away, but it seems to be some weird Gmail quirk. I'm not sure who uses it or why it's there, but I mean, if you want to try it out, it should still work if you're watching this video. Then I've obviously, like, Gmail was, for a second I thought I had cross-site scripting there. It was not the case, but I tested some other email clients as well, and they were actually vulnerable. So I cannot name them in this presentation. I didn't get disclosure permission, but if you ever are testing an email client, also make sure to test whether they properly escape email addresses themselves. Okay, and then email validators. So, okay, we have made all these creative and cool payloads, but we still have to insert them somewhere in an application, and most of them have a pretty strict email validator. And even if your email is correct for the RFC, it may not be correct for the web application. So, for example, with Facebook, you can simply sign up with this. It would give an error. And I was testing GitLab. They have a public HackerOne program, and I also tried to insert my email address with the cross-site scripting payload. So I signed up with this one, and luckily the username was available, but I couldn't sign up with the email address. So I took a step back, and then I saw, okay, but you can also actually sign up and register with one of these services. So if I can get this email address in one of these services, it would still end up in my GitLab email account. So I made this table of all services that would actually accept my email address that contained a cross-site scripting payload and was actually also valid according to the RFC. So these services did nothing wrong really. It was just GitLab that was not really prepared for it. And I tried to sign up. So basically this was the first case I tried. I tried to sign up directly to GitLab with this email address. Didn't work. Then I tried to sign up with GitHub, and then once I had the GitHub account linked to that email address, I would sign up with GitLab for GitLab, and it would actually contain my email address. So that's what I did here. As you can see, this is me signing up with GitLab, and then signing up with GitHub, and then signing up with GitLab. And then as you can see, my email address, including the payload, got added to my account. So this wouldn't have been possible through the normal registration form, but it was possible by abusing a single sign-on provider. Unfortunately, GitLab has their things together, and there was no cross-site scripting issue here. So I had a cool email validation bypass, I would say, but I mean, that's not something you would report. So I started digging deeper, and I eventually made it to account takeover. Unfortunately, not on the main GitLab account, but I'll dig into it right away. So while I was doing research, I also noticed that Salesforce would actually also allow people to use their single sign-on if you had not verified your email address. It's documented, and they assume that the vendor should probably, I mean, they have a parameter to check whether the email is validated or not, so it's not Salesforce's fault, but the vendor should do an extra check to make sure that the email address received is actually verified. It's not Salesforce's job to do that. It's the third party that integrates with them. So I basically tried the same trick, and I was wondering what would happen if I would try to sign up with the email address of a victim that was signed up with GitLab. So this is linked to a valid GitLab account. And then tried to, obviously I couldn't sign up with this again. It would just say, okay, this already exists. But then sign this email address up with Salesforce. I didn't have to confirm it, and then signing up with Salesforce. And if GitLab wouldn't do the extra check, I was thinking, okay, what would happen? Maybe it would result in account takeover, maybe the system would crash, I'm not sure. So the only way to find out is to actually try it. And Salesforce, as you can see, this is the response, and they clearly have this field that says, okay, email verified, and all would depend on the fact whether GitLab would actually check that or not. So it's an interesting edge case, and usually in the case of edge cases, developers tend to forget those. So that's always interesting to search for security vulnerabilities. So as you can see, I just signed up for Salesforce with an email that I can possibly have, gitlab.com email. And as you can see, I actually also went in the API, and my email verified flag was set to false. So no fault on Salesforce's side here. But then I tried to sign up with it, and as you can see, the account got created. It didn't work, however, to hijack existing accounts. What would happen if would be that it would just create a duplicate account with the same email address. But then I noticed I was doing some Google dorking and some recon. Then I noticed they had this forum that would allow people to log in with GitLab. So I was like, okay, if I can't take over GitLab accounts, maybe I can do the second best thing and take over integrations with GitLab, for example, the forum with this button. So let's do a quick recap. Obviously, my victim example.org already existed in GitLab. I couldn't just sign up again and log into their account. That wouldn't work and would be a serious security vulnerability. But I could obviously sign up for it using Salesforce, and then I could sign up with Salesforce for GitLab, and I would just have the same email address on a GitLab account, but it wouldn't be the same account. Those would be two different accounts with the same email address, but with a different ID. So then I noticed that they had this discourse forum linked, and you could use login with GitLab, and the thing they would check was the email address. But since this email address would equal this email address, for the integration, we would be the same person. So I could hijack and take over any integrated service with GitLab, which is not as cool as main account takeover, but it was still a very nice vulnerability. And this is an actual demo of it. So I signed up with security at wearehackerone.com, and then I also signed up with this, but I didn't really confirm it. I was just playing the attacker that doesn't have access to this email address. And as you can see, this is just my Discourse forum account. Here is my avatar. And as you can see, this is the fake GitLab account, and it's basically just the same email address. And then if I would go to the forum, I would say, okay, I want to sign in with GitLab. I would say, yeah, just have my email address so you can check who I am. But obviously I just took an unverified Salesforce email address, and here you go. We were logged into the same account, and as you can see, the avatar is the same. So it's the same account, and you could see, for example, the messages or posts as that user. It obviously got resolved as a critical, and I do have to thank Ron Chan, by the way, because he initially found the way to bypass email validation through Salesforce, but what he didn't find is the actual account takeover part. So the next step that I took, where I would go and see if there's any integrations and take those over. So in discussion with the GitLab team, we agreed to split the bounty, even though my bug was technically a duplicate. We ended up splitting the bounty in the end, but they did raise it thanks to me. So it was a win-win for both of us. All right, so now we covered the email addresses. Let's take a look at the emails themselves. Emails usually contain an email body, and they may contain a file or an attachment attached to the email. There are also email headers, but we won't discuss them in this part. So let's take a look at the email body first. An email body can be made up of text or HTML. Or you can both of them. You can have both of them in the same email, and depending on the settings, one of both will display. You could try to insert JavaScript, but on most systems like an Outlook or a Gmail, this will not run. However, I've discovered some legacy ticketing software that was vulnerable to blind cross-site scripting. So I made just a list of public bug bounty programs, sent cross-site scripting and blind cross-site scripting payload to their support desks, and actually 3 of those actually fired. So I crafted it with the Mailgun API should you want to try it yourself, but make sure to read all spamming guidelines and to ask permission first. If you do see that they use a custom or a legacy support software, for example, written in PHP, this is the example that I stumbled upon a couple of years ago, and their customer service ticketing system would just upload all attachments, send over email to their server as executables. So I would just write the normal support inquiry, and then I would attach a PHP file containing a blind cross-site scripting payload and some PHP command, for example, PHP info. And then my cross-site scripting, like my callback, once the customer service agent opened it, I would receive an email with the actual content or the actual result of whatever I executed. So you can consider it as blind RCE basically. It's not really social engineering because there's a technical vulnerability involved, and I only found this one, so it's quite rare. And then last week, this came out from Maxim Skorbiak, if I pronounce that right. It's not my finding, but it's definitely an interesting one. And he noticed that some email parsers would actually, for certain purposes, email templates would include local files, for example, a logo, and then before sending it, it would upload as an attachment, and it would be rendered as an attachment here. It would be referenced. And then he found that if you would have a HTML injection in an email and just say, okay, I want to, for example, etc password file, then it would just dump it as an attachment and try to render it in the email. So whenever you stumble upon an HTML injection in an email, always make sure to test that. You may get lucky. So that's it for emails themselves. That's not really, except for the body and the file, there's not really a lot of test over there. And then there's also email mechanisms, for example. Email mechanisms, that's basically everything around emails. Those can be features of email clients, but also ways people integrate email into their systems. And obviously, because I was testing these things at a large scale, I did have some issues with bug bounty programs complaining about spam from my testing. It's always a very thin line. You do want to perform research that nobody did before. You do want to go the extra mile, but on the other hand, you do want to keep the noise for the program as low as possible. So I tried to stay under the radar. Unfortunately, didn't always work out. So whenever you send an email, it either arrives or it bounces. That's it. And so what I was telling you is if you're testing this, please seek permission first, reduce your noise, and also if you can, just write what you're doing or use your HackerOne, We Are HackerOne email addresses that make it easier to track you, because you don't want to spam the customer service with all kinds of weird tickets, because a lot of other people will be doing that as well. So always make sure to reduce the noise and seek permission first. So I was talking about the anti-spam functionalities, so I try to stay under the radar, and by doing so I read this RFC about anti-spam measures. People have been dealing with spam for a long time, and this is something from the 90s that already mentioned how you could unsubscribe for a list, for example, or mention something as spam. You could provide an email header with a URL. But every time I see a URL and in a parameter, it basically screams SSRF. So I just put my own my own host in here and a ping back to my machine, and then with permission of the bug bounty program I spammed one of their email addresses and I got an immediate ping back. So what their system would do is, once they've identified me as spam, they would just ping my list in subscription email, my list in subscription URL here, to make sure it would stop, because in normal situation this would unsubscribe you for the list. However, in this case it was just SSRF and I could have them redirect to internal resources, for example, so they did fix that. It was in a firewall solution, so everything went automatically. Nobody had to press a button, this is spam, just went automatically. So I think it was a rare scenario, but it was nevertheless a very cool one, and it also got a pretty decent bug bounty. So one thing I would advise you when testing stuff like this, even if you have permission, is to verify whether the email addresses you want to send emails to exist first. So there's different ways to do that. You can use this verify SMTP command. Just Google it if you want some more info on that, or you can try to log in and then set the RCPT2. Then you can, in some cases, you will be able to see whether the email address exists or not. If you think this is too complicated, don't cry. There are services to do this for you, and some of them are free, so you really have no excuse. So moving forward, what I always try to do when examining the email infrastructure of a company is try to figure out what email addresses exist, or what email aliases and what services they've been linked to, and I call this email recon. And these are some pretty common ones. These are mostly linked to customer support. Then you have the more ticketing systems, and these are all kind of weird integrations, usually custom for the company itself. This is a very basic example of an active HackerOne program. I just sent an email to test at mabox.com and I got like this half a sentence back. And at first glance, it doesn't really reveal anything. It's just an auto reply. But if you would look deeper and open the email headers, you would see that it was sent from a specific service. So even if the original email doesn't tell you a lot, it's always worth to see, okay, what kind of system was this sent from, and usually the email headers will, or the email original message will reveal that to you. There's also autoresponders. Most of you will know that from the classic, oh, I'm out of office, especially now during the holidays. But what I found was that there's two kinds of out of office. One, you have the one intended internally, and these may contain internal email, like email addresses or forms or whatever, and just trying to help your colleagues. And in the other instance, you want to send a message to people outside of your organization and say, okay, I'm not available, but I'll handle your request after I'm back. So you won't reveal as much info as you would to your colleagues. In this case, for example, it's just an example, it would give away a password. But how does this work? So basically, it's kind of simple. You would send an email address, and then the server would say, okay, is this actually originating from the company? Yes or no? And if you're not from the company, you would get the default response. And then I noticed that if you could also set the reply to header. And you could just have it reply back to whoever you want by specifying somebody else as your reply to. You don't really need to own that email address nor have access to it. And I figured that some of these installations would not check the from email address to see if it belongs to company.com. But no, they would check the from email address, I'm sorry, but they would still reply to the reply to. So what I would do is I would spoof the email and make it appear to come from company.com. And then once it reaches the server, it would see, okay, this comes from company.com, it's valid. And then it would reply to my own email address, which is an email address of the inbox, obviously, that I can access. So I would be able to exfiltrate the passwords. This is an actual example I got from one of my bug bounty assessments. obviously heavily redacted. Then there's also email bounces, which are never fun unless you can exploit them, of course. So a couple of years ago, I found a bug in Google Docs by accident. I just found a link to Google Doc somewhere in a GitHub repository, and I just pressed the request access button. And basically what would happen whenever you would press it is Google itself would send an email from your account to the owner's account, so originating for your email from your email address, and it would contain the link to the document, the title, and stuff like that. But in my case, the recipient's inbox was full, and because the email originated from me, it would just bounce back to me because the system was thinking I sent the email. So the recipient's inbox was full. And I found out about the owner of this document, but also I saw the title of the document and the link in the original forwarded message. This was information I would otherwise not have access to. Obviously, I just got lucky because you can't really expect somebody's inbox being full. You really can't control it. And this was the moment that I was thinking, okay, how can we make sure a bounce like this happens without having control over the status of the recipient's inbox? And then I found out about a DMARC policy, which would basically evaluate your SPF or DKIM records, which would basically ensure that an email is authorized and is permitted to be sent from your domain. And this is basically a policy that would define what would happen if one of these policies would fail. It can be rejected, it can be accepted anyways, or be deleted or quarantined, or you know, whatever. You get to decide what happens here. So I would set it to always bounce, and in order to do that, I would just say, okay, reject everything, make sure to send a report to this email address so I can read it afterwards, and then do this for 100% of the cases. This is basically the way to make sure all the third parties or the Googles or whatever application that tries to forward an email originating from your domain would just send whatever it would try to send back to you. Okay, so this was an example of an email forwarder. And if in case you're wondering if there's any other uses for it or any other kind of forwarders except for Google Drive, for example, in the wild that you can exploit, well, there are, and maybe at places you won't expect. One example I came across is ransomware. Sometimes when you get infected by ransomware, the criminals will leave an email address for you to ask questions to, and what will happen sometimes is that all incoming emails will automatically be forwarded to another email address, sometimes linked to the attackers themselves. Obviously, you can tell what email address this is going to just by sending an email to it, unless it bounces back using our technique. So what I did was I would send them an email address from an email domain that was prohibited to be forwarded, so their forwarder would try to forward it to their original email address. In my case, it was a Gmail address, and I would receive this response back. So like you can see here, the full Gmail address would be revealed in the bounce back, and the best thing is that the attackers would not notice anything because they wouldn't even receive my email, and I would still unmask their original email address. Another way forwarders are sometimes used are in bug bounty platforms. For example, Integrity, HackerOne, Bugcrowd all use email forwarders to make it more easy for their hackers to sign up somewhere and you know, just keep better track. And what would happen if you sign up somewhere is this would just forward whatever you send to it to your HackerOne or Integrity or Bugcrowd associated email address. And I tried this technique with this, so I tried to send an email to my integrity.me email address, so my alias, using a domain that was intended to bounce everything back. And I noticed I could actually reveal everybody's email address just by sending them an email at their integrity.me email address and have it bounce back right away. And then one last case I've seen this work is in multi-tenant environments, and that was actually kind of interesting because it resulted in account takeover. So sometimes what will happen is you have this SaaS app and you can add it to your own domain, run it on your domain, but the user management would still be kind of centralized. So you can, for example, we have 2 users and they have their workspace, but John could invite Alice to their tenant, and with the same account she would have access. So if John would trigger a password reset mail, it would be sent from john.io because the SaaS app has permission to send from john.io, and the email would be being sent to john.io, nicely branded. Now imagine that John adds Alice to their environment and resets the password for Alice, but just at that moment John adapts the DMARC settings and makes sure that the validation fails and the emails gets bounced, it gets rejected. Then john.io will try to send Alice's password reset email that would actually also be valid for her own tenant. So she sends it, but of course we have a strict DMARC policy and it will bounce back because the SaaS app is not allowed to send from john.io, and everything works, but still John ends up receiving Alice's access token. In a real life scenario, and this is a screenshot I took from an actual bug bounty submission, it looks like this. So you have the email attached, and if you would click this, you would see the full emails with all headers and a password reset link. So this is the whole situation that would occur, and actually would allow John to reset Alice's password and thus access her own workspace, resulting in full account takeover without user interaction. I found multiple of these, so it's always very interesting to see if you have this kind of setup, whether you can bounce other people's password reset tokens. That would be a horrible thing. So I think we covered it all for today. Thank you for attending this session. I look forward to your feedback, and I also look forward to seeing more people doing research on emails and email addresses in general. Thank you.